Twitter, some teacher does dum-dums because like the teacher made a mistake, so you had a dum-dum. I don't really like to call myself dumb though. No. Don't follow me on Twitter. I don't actually tweet. Okay. What did Victor say? Anyway, we're here with our P3 class, ready to run a 2-sample T interval. So, what's the first thing I'm going to do? Assume, right? Even though they say don't assume, we're assuming, right? I don't need any parameters. I don't need hypotheses because we're running an interval, not a test. So tomorrow on the quiz, you will need to do the parameters. You will need to do the hypotheses.
Also, tomorrow will be a test.
You're right.
That's only with tests, right?
Correct. All right. So I heard, Victor, you said assume. What are we assuming first? What would you like to assume first? Oh, you want to just go straight to this? Okay.
So
You can do that. So I'm going to assume, this is where I would say the problem states the population histograms are normal. Otherwise, I'd have to assume that they are. And then tomorrow, wink, wink, when you get your data, what are you going to do with each of those samples? Put them in the list to make the histograms. All right, so you got to make the histograms to see if they are roughly symmetric and unimodal. Okay? All right, do I need to do that for this? No, I don't have any data, right? I just was given statistics, all right? And it tells me you don't need to worry about it because I'm telling you the populations are normal. Exactly. All right, interesting. I would not have done that first, but we can totally do it at any order you want. All right, so there's two independent things you got to do when you're doing two groups. All right, the first one we just have to say is one accident is not going to affect whether another accident happens or not. So I'm going to write that first. So one accident will not affect other accidents. All right, now we've got two departments here. We've got Department 1 and Department 2 at an assembly plant. So now we also have to assume that if an accident happens in that department, is it going to affect this one? No. So we have to assume. That's called the independent groups assumption. All right, that is something I will be checking for tomorrow. So one accident happening in Department 1 will not affect Department 2. Now, we don't know if that's true or not. We don't really know a whole lot about this assembly plant. All right, so we should check a few things. Let's check for randomness. Did it say anything about random sample?
No.
It did not. So remember our favorite sentence?
This sample is a good representation of the population.
Very good. I'm going to do these 30 months are a good representation of all months. So when I was growing up, my dad was a safety engineer, right, at a power plant over in chemical plant over in Pasadena. So on a few times, take your kid to work day, right? I got to go, and they had like that wall with like the sign that says this many days since the last accident, right? Well, that was like the big thing is we want to make sure we're not having any accidents, right? And so a lot of times when I would go, I didn't go that many times, but when I would go, it'd be like many days, like hundreds of days. And one time I went, it said 3. And I was like, Dad, what gives? He's like, it was a tough day. All right. So whenever I think about accidents, I think about, going to my dad's plant for a while. Anyway, this is not random, right? We're hoping that these 30 are a good representation. I bring it up because, like, say last month we had 25 accidents, right? That would be a lot. So we're hoping we don't have that happening in these 30. Okay? Let's check the 10% condition. What is n times 10? 300. All right? So we have to hope that this assembly plant, like this company doing the whatever they're making here, has been in operation for over 300 months. What is that in terms of years? We have calculators.
Oh, yeah, we do.
It's 25 years. So we are hoping, right? I'm hoping this company has been in operation for over 25 years. If it has, then I'm not worried about my sample size being too large. Okay, now, sorry, Bardo, go ahead.
The 30 months are a good representation is for the random.
Yes, this right here is taking care of the randomization condition.
Okay.
We're hoping, right, hopefully tomorrow, it says samples are random. Leslie. So the first one is what I would actually do now. So now is when I would do the normal population assumption, which is actually what we did first. So really, Victor, I would put that here. It doesn't matter, I don't care, right? But I would put that here, right? And then Leslie, tomorrow when you've got data, you're going to actually, thank you. You're going to then do the nearly normal condition, which is make the histograms. So I want to see that you check that tomorrow. Okay. All right, so we don't need to do that. So we're actually ready for our last sentence, which is the conditions have been satisfied. So I will use the T model with, do I know how many degrees of freedom? I don't know yet. So what you're going to see more is when you do two sample things, two sample T intervals, two sample T tests, you just want to like hold off and let the technology tell you what the degrees of freedom is. So leave a blank, degrees of freedom. To run a two sample T interval. Thomas.
Sorry, this is a dumb question, but how come we don't run the DF here?
I could show you the formula to find it.
No, because like wouldn't it just be 30 minus 1?
It's not. We have two samples of 30. That's why. If it was just a one sample T interval, we would know it would be 29, correct. But because I've got two of them, I don't want to just say what it is. I don't know what it is yet. Okay? Good question. It's not a dumb question. Yeah. Right, there are no dumb questions. Are we ready? What? That's only for two. If it's a one sample T interval T test, you should know the degrees of freedom right away. N minus 1 every time. Okay, so let's write down what we know. We know the sample size for the first department is 30. The sample size for the second one is also 30. The sample mean, what was the average number of accidents in the first one? Something like, is it 12 or something? 12.3? 12.3. What about for the second department? 0.6, okay. And then the standard deviation for the first one? And the second one? 3.4? All right. Let's write down the formula. You will get this formula tomorrow. You won't probably need it, but maybe you do, because there will be two multiple choice questions on the back. Well, there's a free response, which is like the bulk of it. Plus or minus T star times the standard error. Oh, I wrote a P. y bar 1 minus y bar 2. Here's the formula for that. I know, right? Gosh, this is so much fun.
So much fun.
Oh man, I love stats in high school. So much fun. My teacher, Mr. Polk, I think I told you this, he has the same name as I do. His name was Doug, also Doug. Sick. Only teacher I've ever had the same name. And he would, I don't recommend this anymore. This is back in the 2000s. He would have a spray, like water bottle that he would use to spray this is a long time ago, guys. So wait for it. He would spray like the sheets, like the lamination to like wipe off the V marker or whatever it was, right? You probably don't know what that is, right? Anyway, so when a kid would fall asleep, he would pull it out and just spray them with water. Yeah. So man, my friend Rhett, so much. No, I don't want to get fired. Oh, man.
It was allowed. It was like
It wasn't really allowed. It was like frowned upon.
What would you do if it was allowed?
No. But if you want to do something like that tomorrow, it's a shameless plug. Tomorrow during B lunch, you can pay $3 to throw a pie at me. If you, I'm on the roster, baby. Called up to the big leagues. Cash only. Cash only. We don't accept anything else. Cash only. What? Oh, yeah, we're doing a pause. Yeah. Yeah. Yeah.
We also have Mr. Hudson, Mr. Hernandez, Dean Chu, not Jones though, not yet. I told him. We almost got him. Mr. Sharp. Mr. Sharp.
Yes. Mr. Sharp too? Oh,
Mr. Gravy, Mr. Gamba. We have like 10 teachers. We need to write that down.
No, they'll bring all the stuff. You just bring $3. Every time you want to do it, $3 for me, $5 for the admin.
$5 for Mr.
All right, here's the formula. Yeah, I need to edit this out. That's the formula. Yeah, you take the standard deviation of the first one squared over the sample size, then add it.
Wait, is that 2 minus y?
No, you're thinking of finding t, the test statistic. That's for a test. This is for an interval. This is going to replace the standard error. Just
That's square.
it is a square. It's s with a subscript of 1 squared.
I thought it was Z. I was like,
Listen, man, it's not perfect. I'm sorry. All right. No, it's all right. I'm just waiting for him to come finish the quiz. Okay, so let's go ahead and got it on the recording. Minus 7.6 plus or minus. Remember, do I know T star yet? No, because if I want to know T star, I got to know the degrees of freedom, which I don't know yet. So leave the blank there. Times. Let's plug everything in. It was 3.5 squared over 30 plus 3.4 squared over 30. Do these need to be the same? Do 30 and 30, do they have to be the same? No. All right, we'll do one here soon where it's not the same sample size. It's okay if they are, but they don't have to be the same for a 2-sample t-test or t-interval. I've had kids ask me, do I need to show all this work? No, right? I'm looking for the setup and then the interval. I just think it's good process and habit to show your work, right? Then I can see if you made a mistake, where the mistake happened. All right? Are we ready to transition to the calculator? No?
okay, yeah.
Okay. Let's do it. When it's a t-test, you're going to find a t-test statistic. That's what he was saying. Like t equals the difference, this difference, usually minus 0 all over the standard error. That's the other formula you'll get.
So the standard error is different for intervals?
No, it's the same for intervals and for tests. You want me to show you the formula sheet? I'll show you the formula sheet. So this is the one that we're doing right meow. We're doing this one. Okay? And you're talking about this one, which is tomorrow's. Later today, you're going to use this. And tomorrow's quiz, you'll need to do this. Yes. The change of the null, we just always assume this is 0, that there's no difference, right? Unless they tell you, right? They might tell you, like, the difference is 5. No, I usually, if it's 0, I just write that. But if you want to write -0, you can. Again, that's tomorrow. Okay, so I'm going to go to stat, over to tests. Does anyone know where the 2 sample t interval is? It's actually number 0, number 10, number 0. Stat. Over to tests. Oh, you're saying yes. We're going to do stats. You're right, Thomas. They didn't give us I didn't get 30 data values from Department 1. I did not get 30 data values from Department 2. They gave me sample statistics. That's what that stats represents. So I'm going to click stats for statistics. The first one, was it 12.3? 3.5? 30. 7.6, I think. 3.4. No one said anything, so I hope that's right. Thank you. What level of confidence? 95, but if that's 90 or 99, please change that. And then, do you guys remember what we said about pooling?
No.
Yes, click no.
Interval no.
Even for a test with means, you're not pooling. Remember, what does pool start with? P. Proportion starts with a P. Only pool when you're doing 2 proportion Z intervals or 2 proportion Z tests. If it's not a proportion, we're not pooling. All right, so P, think alliteration, right? Where do you pee? In the pool. Okay.
That's what I said. It was a joke. It was a joke.
It was a joke. It was a good joke, Thomas. Thank you. Okay,
It's a joke.
let's write down a couple of things here. Notice the very first thing is the interval. So let's go and write down this is the answer, right? 2.917. And then 6.483. And they also have the degrees of freedom is the second thing. You guys see the degrees of freedom? 57.951. So I'm going to write down the degrees of freedom a few spots. So 57 up here, 0.951. And before I write the answer, and again, you do not need to do this on the AP exam. I just want to make sure I'm being consistent on what I'm trying to teach you. We just ran a confidence interval with 95% was our confidence level. So what is in each tail? 2.5%. Okay, so if you would like, you don't have to, but if you want to hit second vars and go down to inverse T, so second vars, inverse T, the area is 0.025, and the degrees of freedom, I think, was 57.951. Again, I'm rounding. If you want to get an even more accurate T-star, you can keep going, right? Don't need to round. I'm not worried about it. All it's going to change is like the number in the thousands place or the tens of thousands place. So I'm not worried about it. It's super far after the decimal. Say it again. No, it will not. Like the AP exam, it doesn't matter. So the T-star is 2.002. This right here. The reason I want to keep doing this, and you're like, why do I need to do this? I don't need to know. Well, you might be asked, what is the margin of error? And so you might need to find that T-star to do it this way. So typing that in is the margin of error. Or what most students will do is they would find this difference. Do you know what this difference is?
Something.
You have a calculator.
I just didn't want to type it.
What did you write for inverse T? I didn't get it.
What was it? 4.7. And if you take 4.7 and either subtract this number from it or subtract the higher number from that, you will find the margin of error, which is the same as that in the rectangle. If you're not there yet, it's okay. We're still in February. But if you're not there in May, we got problems. Eduardo.
You always write 0.025 for the area.
If the level of confidence is 95. But if it's 90%, then it'll be different, right? Then I'm splitting 10% in half. I would then 0.05 correct, right? So it depends on what my confidence level is. So if you were to see like me taking the AP exam, I would have a lot of these written, as like my work. All right, you ready for the sentence? Ready for the sentence? I am 95% confident that the average difference in the number of accidents between these departments is between 2.917 and 6.483. Wait for it. Oh no. I don't know. I'm worried.
Oh my god.
It's buffering.
Did anyone else record this?
He's gonna start recording.
Oh well. We'll try again later. Okay. Before we finish up with this problem. Oh, that's actually context between accidents, departments. That's my context. I want to make sure we understand the linkage between what we just did, all right, and what we would have found out if we had run a test with these sample statistics, okay? This is guaranteed to be on the AP exam, whether it's with means, proportions, or something you'll see later on in the next few chapters. You will be asked about this question, okay? So if you look at the interval, right, I think we would all agree that we would rather not work in Department 1. Why would I not want to work in Department 1?
More accidents.
There's a higher average of accidents per month, right? Definitely sign me up for Department 2. Okay? Now, you're telling the boss, wherever the boss is, that on average per month, right, Department 1 is having between roughly 3 to 6.5 more accidents than Department 2. Okay? And what do you notice is not in that interval? What is not in that interval?
I mean, a test would
Enzo's got it.
change.
Can you say that out loud for us, Enzo? 0. Right? If 0 is not in this interval, that means that we cannot even begin to think that they are the same. If I did see 0 in this, then there's a chance that the average number of accidents in these departments is the same. But since 0 is not there, we would reject 0. And if we're rejecting 0, that means we are saying that they are significantly different. Okay? So if we had run a test, we would have had enough evidence to reject that they're the same. We would have actually concluded that they're different.
Those two intervals, the 2.917 and the 6.483, those show